So this is our first day of review for the test. For some kids, they're actually going to want a test tomorrow, but if you're ready for the test tomorrow, you can take it tomorrow. And here is a triple Venn diagram question. I'd say the hardest kind are where they give you info and you have to build it. All right, so let me give you some info. Let's make this the same, everybody do it the same as I do it. This is for dog, and that means that if you're in that circle, you have a dog, okay? This next one is for cat, and this last one is for piano. And of course, there might be somebody in the room that doesn't have any of them. Now, I'd like to just, you know where you would be in this circle. If you have a dog and a cat and a piano, would you please raise your hand? All right, we got 0 of those. Just to make sure we don't have like 0 of a whole category, just real quick, who has a dog? Raise your hand if you have a dog. Okay, stop, hands down. Who has a cat? Raise your hand if you have a cat. That's only 4. That's going to be pretty small. How about piano? Raise your hand if you have a piano. That's a fair amount. Okay, we're leaving the piano in there, but we're going to replace the cat with something. Name a restaurant that's very commonly liked. Chick-fil-A. How many of you like Chick-fil-A? All right, that's a lot of you. We'll do that one. All right, so you either like it or you don't. Like if I said, hey, you want to go to Chick-fil-A, you'd be like, yeah, or no, I don't like it. Maybe you don't eat chicken. All right, so who then, now that we have that combo, likes Chick-fil-A, has a dog and a piano? Raise your hand if that's you. 1, 2, 3, 4, 5, 6. Okay. Who has a dog? Raise your hand if you have a dog. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Where do I put the 19? Only here. It's not really in the chart. I can write it somewhere, obviously, but the logical place to write it would be right after dog. Because I can't put it there. What's that spot for? Only dog. All right. Who in here has a dog, but again, it's going to be only dog. So you don't like Chick-fil-A and you don't have a piano. Raise your hand if that's you. All right, so we got none in here. Okay. Who has a dog and likes Chick-fil-A? Raise your hand if that's you. Dog and likes Chick-fil-A. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Where does that go? No. Most common mistake on the test, right there. You see how they would think that's dog and Chick-fil-A? All I asked was who likes dogs and Chick-fil-A, and that's 9. Who can tell me what I actually should write here? Say it. 3. Process that for a second. The 9 was these two together. And the way you can ask yourself that is this. If you ask these people, do you like dogs and Chick-fil-A? If that's all you ask them, they would say yes, wouldn't they? So they're part of that group of 9. And these people, do you like dogs and Chick-fil-A? And they would say yes. That's a great way to do it, is to think about asking those people. Okay. All right, so now, who in here has a piano and likes Chick-fil-A? Just answer that question. Has a piano and likes Chick-fil-A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where should I put that? Yeah, it's kind of here. But then what do I put here? 4. There you go. You're catching on to that. It's a really important skill because kids think that every number I give them just goes right into chart. Actually, it's not true. Almost none of the numbers go right in the chart. The only number that would have gone right in the chart, if I gave you it, was the 6. Because if I said 6 people have all of them, boom, you could put the 6 in the center. And that's usually the key, is the center one. All right. Now, everything I've given you so far is about dogs, Chick-fil-A, and piano. You're just going to stay out of the voting for now, okay? Because you were gone when we were doing the original voting, so just don't vote anymore. Who in here has a piano? Raise your hand if you have a piano. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Where can I put the 16? Do I put it here? No, don't do that. The 16 piano is here, and then that'll inform us later about what these two numbers together have to be. Do you get together? Those have to be 6? Because you already got 10 people that like a piano. They're already there. All right. So who in here has just a piano? You have a piano, but you don't have a dog, and you don't like Chick-fil-A. All right, that's a 0. Who in here has a piano and a dog? Raise your hand if you have a piano and a dog. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Piano and dog goes on the outside here because together these are 11. Do you get this has to be 5 then? So even though they gave me an 11, I only put in a 5 because together those things make 11. All right. Now, I just want to finish this thing, so I'm just going to write down a couple numbers. I am curious about one more thing. Who in here doesn't have any of them? No dog, no, you don't like Chick-fil-A, and you don't have a piano. All right, one person. Do you have it?
No.
You're not there? Okay. All right, so then there's nobody. All right. Do you get that there's only one spot left? I can get that by just knowing how many of there are. So I'm going to count that. 2, 4, 6, 8, 10, 12, 16, or 14, 16, 18, 20, 22, 24, 26, 28, 30, but I don't count you, so 30, 32. 32 people. So if there's 32 people total, I would always put that up here. Do you get that that's kind of like a logical place for the grand total of everybody? Okay. Then I have to add up all the other things on the chart. 6 and 4 is 10, plus the 5 is 15, 6, 17, 18. And there's going to be a lot of people in this category, isn't there? Because there's a total of 32 of you. And so far, we've only got 18 on the chart. I'm going to erase this little 10 so you don't get confused about what that is. And I'm going to erase this little 11. All right. So do you get by logic? I can know what this last spot is. Because they have to add up to 32. And we should.
If the number of people that like dogs is 19, how come the numbers in the dog circle add up to 14?
Ah, that absolutely cannot work. You are correct. So I knew this was going to happen. Somebody in here has changed their opinion and, like, by accident, raised their hand for a dog that doesn't actually have a dog, or got confused about, you know, the other questions. So I get what you're saying. I do. So this 19 can't possibly be right. Either I counted wrong. Like there was a kid who had his hand on his head like this, and I didn't know if they were raising their hand or just supporting their head. So anyway, you're right. You're right. That can't possibly be right. So I will actually add those all up and go 6, 7, 8, 9, and 5 is 14. This has to be 14, or one of the other numbers is messed up. Okay, so that's just me counting people. It's just trying to make it more interesting because you know where you are on that chart. All right. And let's do the last one. Chick-fil-A only. You don't have a dog. You don't have a piano, but you do like Chick-fil-A. Raise your hand for that spot. All right. 1, 2. Only 2. All right. Now, if this was all, if I asked you the questions, well, I asked you the questions I asked, but if you guys raised your hand perfectly, then this should add up to 32. And it doesn't even close to add up to 32. So either people got confused. There's clearly 32 of you. I counted that. I'm pretty sure about that one. All right. So the 16 piano, this only adds up to 15. So that can't be right. So I'm going to just fudge some numbers now, and I want you to do the same. We're going to erase this. We're going to erase this. and then we're just going to put in a 3 here at the bottom, and we're going to call that good enough. Because I want to write some questions about this. There is a practice problem about making the Venn diagram, and it absolutely would have worked out if I would have counted properly and everybody would have answered properly. But it's life. That's how that works. If I now add them up, I have 10, 15, 23. I have 23 people that in this imaginary survey now. Okay, so now can you answer these questions about it? Here's an easy one. What's the probability that that person has a dog? If you got 14, that's a great start, but that is not a probability. What is it? 14 out of 23. Raise your hand if you had that one right. Okay, good. Next one. So for some reason, this will get people. What's the probability that you have a piano? Grab a random kid, and they have a piano. Do you find yourself wanting to do 3 out of 23? Because that would be wrong. But people do it all the time because they're like, that 3 is for piano. Yeah, but all the other ones are for piano too. I think it's 18. Raise your hand if you had 18. Nice. 18 out of 23. Why would it ever be out of not 23 if I said given? All right, let's do a given right now. Given the person that I talk to next, I'm only going to talk to people that have a dog. So given dog, what's the probability of Chick-fil-A? Given dog, what's the probability of Chick-fil-A? All right, now this gets at the most important thing in probability, which is it's what you want over what's possible. And whenever I say given, I just change what's possible. Whenever you say given, you change the possible. So given dog means the only things possible are these. And that's 14. 14 possible. What I wanted was Chick-fil-A. And that's this or this. And or means that you'd add them. And so that's 9 out of 15. 14, sorry, 9 out of 14. Raise your hand if you had that one right. Okay, good. And then the hardest kind. Not. What's the probability I grab somebody and they do not have a piano? I grab a random person and they do not have a piano. The not piano was only 5 people. 5 people were possible. So then it's 5. Well, I could have picked anybody though, right? 5 out of 23. Now I'm going to change the given. Given that there was no dog, given no dog, what's the probability of piano? Given no dog, what's the probability of piano? All right, given no dog part meant that these are the only things left. And there's 9 people that are possible. What I wanted was piano. out of the ones I circled, only those are possible now. Which ones had pianos? These two, 7. 7 out of 9. Raise your hand if you had that one right. Okay, good. I think you're getting the triple bends. Yes. Okay, so that one was given no dog. I want you to look at no dog. That means I'm not doing this, I'm not doing this, or this. The only ones that were left, the 2, the 4, that makes 6, plus the 3. And it would have been this also, but there was no people out there, so. You know what I mean? I can add in a 0 if you want, but, okay. All right. Now, there's 4 parts to the test. That's one part. Here's a part that's a lot easier. Everybody make this little marble drawing. We're going to make 1 red one, 2 blue ones, and 3 green ones. Let's keep the first one super simple. What's the probability of blue?
1/3.
Just let's make it not reduced to start with, to make people see it.
2/6.
Yeah, 2 out of 6, which is 1/3, totally. Does that make sense to you so far? What's going on, guys? What are you looking at this so? Okay, all right. So here's a way harder one. If there's 2 marbles drawn, the first one gets drawn and then kept out, and then you draw another one, what's the probability of getting a red, then a green? And again, we're not replacing. Well, the first thing I'd ask myself is just, what's the probability of getting a red? That's just as easy as it was before. And I put it as a fraction. Talon, what's your probability of getting a red? Yep. And then you do the probability of the green, but you've got to remember it's dependent. Depends on what you got the first time. Since I got a red, that's what this says, is I got red. Now, think about what marbles are left. And the green was what you want, which is the green ones, and there's 3 of them out of how many? 5. Now, if you added these right now, it might come out to like 100%. And if you think about that, that doesn't make any sense. If you ever tried to add these, hopefully you'll realize, wait a minute, I'm getting a probability of like 100% that happens? There's no way that's right. It's times them. And one last pro tip, I would put these in parentheses. I would also not do the decimals in my head, because last hour I had a kid take 1/3 and go, oh, that's about 0.33. Do you get 1/3 is not 0.33? It's 0.33333 repeating forever. And that's different, especially when you're rounding to 3 decimal places. If you just say it's 0.33, you're cutting it off and you're going to get it wrong. All right, so please put these in as 2 fractions. I'd put them in parentheses and then get your final answer as a decimal. If you're like, how do I put in a fraction? I've been amazed sometimes. It's just 1 divided by 6. But I put it in parentheses. John. Get the blank notability knocked out, John. Do something else and that's annoying. And frustrating and all kinds of things. Don't make me come and babysit you. Multiply those out. Okay. And Weishan, what'd you get? Raise your hand if you had 0.1. Sweet. All right. Now, given that there was a green one first and a blue one second, what's the probability of getting the red one now? I'm going to say that again. Given there was a green one first and a blue one second, now what's the probability that you get the red one? All right. If you got a green one first, it's gone. I got a blue one second, it's gone. Now the marbles that are left, there's 4 of them. And you want the red one. 1 out of 4. Raise your hand if you had that one right. Okay, good. Any questions about that one? We got a blue one first that took out a blue one. We got a green one first and then a blue one. And I did that by just crossing them off. And then the probability of red was 1 out of 4. Okay. One more thing. I just want to start this because it could be really handy for one of the trickiest questions on the test. Could you make a tree diagram for this? I don't need you to complete it. But would you even tell me how to start it? If you don't know how to start it, that'd be a problem. I'm going to give you an assumption that I'm going to make 2 draws. The first draw, think about all the things that could happen. And then the second draw, think about all the things that could happen. If you don't know how to make a tree, you're about to get that part of the test wrong. There's 4 parts to the test. So, all right. First thing I do is make 2 branches, and I think to myself, can I do this with 2 branches? Now, what are the 3 things that could happen? Red, blue, green. Need 3, because that's the 3 things that could happen. And then, could I figure out the probability of each of those? Yeah, that's not that hard. Now, if I got a red, does that affect, since I'm not replacing, remember? Does that affect the others? Yes, and there's a name for that. It starts with a D. Dependent. Okay, good. Now it could be red, blue, or green again. Now I know some of you are like, but there isn't any more reds. That's a good point. Here the probability of red was 1 out of 6 because there were 6 marbles in the first place. The probability of red here is there's 0 red ones left because you already got one. Out of 5 technically, but either way the answer is 0. And so then the branch here would be 1/6, which is 0.16, times 0, which is 0. There are things that are a probability of 0. You can't get a red one and another red one because you already got it. There isn't any left. Okay. Would you please just figure out these 2 spots right here and the appropriate final answers for these 2? Just figure out those. If you aren't practicing this, this is probably one of your toughest tests. Even though you're just multiplying a bunch of decimals. These are hard. We have math teachers that teach super high level math who cannot figure these out. Seriously. Because probability is so different than normal algebra kind of stuff. I was just talking to a math teacher about that earlier today. I remember one of the teachers that retired. Whenever her kid would get to the probability part of the tutoring after school, like she tutors people for pay, she would send them to me because she was like, I don't do probability. This was like a high-level calculus teacher. So probabilities are hard. All right. So now I'm trying to figure out these 2 and this little branch spot right here and this little branch spot right there. And this is the probability of getting a blue after getting a red. Okay, so there was already 1 taken out, and so there isn't 6 anymore, there's 5. And what I wanted was blue ones, And since I got a red one in the first place, there's still 2 blue ones left. So it's 2 out of 5. Raise your hand if you had 2 out of 5 right there. Good. What's the last part? 3 out of 5. Does this add up to 5 out of 5? Yes, that's a way you can tell you're doing it right. All 3 of those would have to add up to 100%. And then these spots, we already have a 0 here. These have to add up to 100%. They do. No, wait, I'm wrong. You're right. The whole thing at the end will add up to 100%. These don't have to add up to 100%. They have to add up to 0.16 because they're based off of this. But anyway, let's get the final answers for this. What is 1/6 times 2/5? 0.066, except I'm going to round it. 0.067. Raise your hand if you rounded properly. Good, that's an important one. What is 1/6 times 3/5? And if you added these together, they would coincidentally add up to 1/6. But they don't add up to 100%. You'd have to do the whole rest of the chart. And all of these together would add up to 100%. Okay. Here's another kind. Chart kind. Don't copy this chart. Righty, lefty, dog, cat. You're just going to answer questions about it. 3, 4, 2, 8. If I add them all up, 7, 10, 17, 5, and 12 also add up to 17. You with me so far? All right. If I just asked you probability of dog, that would be insultingly easy. So what's the probability of dog or left-handed cat person? Meaning, I grab a random person, and they either have a dog or they're a left-handed cat person. It's a fraction. Please write it down, and I'll ask you to discuss it with a friend in a second. Not yet. Probability of dog or left-handed cat person. It's a fraction answer. Talk to the person next to you, please. All right, you can either use this 7, or you can say these people and these people and these people are what you're looking for. And that'll still get you your 7, but add the 8, and you got 15 out of, it's got to be out of something. Did I ever say given? No, so then it's out of the grand total of 17. Now, I'm going to change it, and it's going to be way harder. Given the person is not right-handed, what's the probability they have a dog? Given, not right, probability, dog. If you're dividing by 17, you're doing it wrong. Because as soon as I say given, it changes this number. Isn't saying not right pretty much the same as saying left? So it was given that they were left-handed, because if they weren't right-handed, they had to be left-handed. So then that makes it out of 12. And the probability of dog, only choosing from those, is 4. I get how some people want to take 7, but no, you'd be adding in some right-handed people. We only can take from inside this circle here. So it's 4 out of 12. Who had 4 out of 12 on that one? Nice. Okay. So, the last kind. And remember, if you don't feel like you get it after this, that's okay. You don't have to take the test tomorrow. Unless you're gonna be gone Friday. Then you gotta, actually, no, I shouldn't say it that way. If you are gone Friday, it does give you the option to take the test after break. But if you aren't gone either day, then you have to take the test either Thursday or Friday. Okay. All right. So, I'm gonna make the last problem a tree again, because I'd say there's more of those than any other question. All right. So this time, you do not have to copy this tree. You can just use this tree. This is, you arm wrestle me and you win or you lose. Then we flip a coin and you get heads or tails. I'm saying that I have a 65% chance I'm going to win the arm wrestling match. I could beat a bunch of you. Obviously, that leaves a fair number of you could beat me. And then heads or tails, it is not 50-50 because we did an experiment, and the experimental probability came up that this coin was weighted, and it was a 60% chance that it was going to come up heads. I would like you to then finish this chart. I know you feel like there's stuff missing, and there is on purpose. Figure out what all four of those are, and then I will ask you a question about it. Now you can copy down what I have and put in the stuff that you can figure out. Stay with me, it's my last problem. Now, I want to warn you, I don't want you to get a false sense of security. The trees are way harder when there's a third set of branches, because all of a sudden you'll have right now we have only 4 things that could happen. If I make one more thing like this, then there could be 8 things that could happen, and it gets way more complicated. But the principles that I'm going to do are the same. All right. I hope you know that if that one's 0.6, then this one has to be 0.4, and this has to be 0.6 and 0.4 again. And this has to be 0.35, just by math, because those have to add up to 100%. Now, what is 0.65 times 0.6? What is 0.65 times 0.4? What is 0.35 times 0.6? What is 0.35 times 0.4? Awesome. Now, I encourage you to stick with the system of what you want goes on top and what's possible goes on the bottom. And as soon as I say given, it changes what's possible. To start with, if I don't say given, what are all the things that are possible? Everything, which adds up to 100%. Okay, good. Given, I'm gonna summarize each one of these. This is win and get a heads. This is win and get a tails. This is lose and get a heads. And this is lose and get a tails. Given, you did not lose and get a tails, what's the probability you won and got a heads? Given not LT, what's the probability that you WH'd? actually divide those two and get a decimal. Because I'm going to ask you to compare it to the kid next to you. As soon as I said given, I hope you said, oh, so then I got to figure out what's possible and put it here. And what's possible was these three. Now you could do that by adding up the three numbers, or you could take 1 minus, this is important, 1 minus 0.14 could go down here. 1 minus 0.14. That's 0.86, right? All right. Now you could have got that by adding up the other three, but there's a faster way. All right. So those add up to 0.86. That's what's possible. What did I want then? WH, win and heads, which is 0.39. Is that what you got? 0.39 divided by 0.86. Talk to the kid next to you, see what they got. What is 0.39 divided by 0.86? Who rounded properly? It would be 0.454. Raise your hand if you had that right. Ooh, okay. Did you have it not rounded to 3 places? The reason I say that is on the test. It's going to be very strict. You have to round to 3 places. Now, it's possible my calculator did this wrong. Did I do it wrong? Sorry, I'm going to go back and try that again. 0.39 divided by 0.86. 0.45, yeah, 4534. Weird. I don't know if it's because I set it into the calculator or I rounded up earlier. That's possible. I like rounded up and then tried to round up again. Okay, yeah, thank you very much. 45384. All right, now I'm going to round it to this spot, and that would be 0.453. Double checked. Raise your hand if you got the same thing as me. Okay, good. All right, now, some of you might feel ready without having to do anything else. And so your worksheet tonight is, this is dangerous, it's optional. Do what you want. If you feel completely ready, then don't practice at all. But then don't be surprised if you end up with a B or a C where you're used to A's. If I were you, I'd pick a few that were scary, because if it's scary to you now, you can imagine tomorrow, far more scary. There's nobody to ask for help, no key to look at. You just got to sit there and struggle. Okay, so I strongly recommend you do some, but I'll never know because I'm promising not to collect this. So just be smart. It's your grade, it's your life. So you could take it tomorrow, or you could wait, because tomorrow I'll do some more of the hardest kind to practice. If you want some more practice, just wait and you can take test Friday. All right. And that's all I got for you for today.